Most of us have experienced the slow decline of a smartphone battery. When it's brand new, it easily lasts all day. But after a few hundred charges, the capacity drops, and you're suddenly hunting for a power outlet by mid-afternoon. There's also a physical limit to how much energy you can cram into a small, solid space. Under heavy stress, these batteries can get dangerously hot, causing the casing to bulge and warp, and in rare cases, even catch fire. Now imagine the challenge of trying to power a whole city with that same technology. You would need millions of these solid cells, all packed together, each one prone to wearing out and sensitive to heat. Using standard solid-state batteries for a city grid means managing massive fire risks and facing the high cost of replacing the entire system once the cells inevitably degrade. Storing energy for an entire neighborhood requires a completely different approach, using circulating liquid instead of solid metal. This is the redox flow battery. The name redox is just shorthand for the way chemicals swap electrons back and forth to store and release power. In this system, that swapping happens inside two giant external tanks filled with fluid. Moving the energy from a sealed solid into an open liquid system gives engineers a way around the lifespan and safety issues that plague our handheld devices. You can visualize how this works by picturing two reservoirs and a water wheel. The water wheel is the engine of the battery, or the cell stack. Its size determines the power, basically how much energy can be sent to the city at any one moment. The reservoirs are the storage tanks. Their size determines the capacity, meaning how many hours or days the battery can run before it's empty. In a typical solid battery, the wheel and the reservoir are locked together in one box. To get more storage time, you have to buy more of everything, including the expensive engine parts, even if you don't actually need more power. Flow batteries change that. If you want the battery to last 3 times as long, you don't need a bigger engine. You just build larger tanks and add more liquid. Because the power and the storage are separate, utilities can precisely size the system for long-duration needs without paying for unnecessary hardware. Since this system is mechanical, you might expect it to wear out even faster than a phone, but it's actually the opposite. Solid batteries physically expand and contract every time they charge, which creates tiny cracks that eventually kill the battery. In a flow system, the chemical reaction happens within the liquid itself, so the physical structure of the battery doesn't face that same internal stress. This lack of physical wear means flow batteries can operate for over 20 years, enduring tens of thousands of cycles with almost no change in how much energy they can hold. Safety is the other major factor. Because the liquids used are mostly water-based solutions, they are non-flammable. You could place them in a fire and they simply wouldn't ignite or explode. This combination of long life, easy scaling, and fire safety makes these systems a reliable choice for the heavy lifting required by modern power grids. These systems are now being installed alongside solar and wind farms to help manage energy that is naturally weather-dependent. Solar panels might produce a huge surplus of energy at noon when it isn't needed, while wind turbines might peak in the middle of the night. Flow batteries act as large-scale buffers. They soak up that extra midday solar power and store it safely in those giant liquid tanks. Then, during the evening hours, when everyone gets home and turns on their appliances, the pumps engage and stored energy is sent back into the grid to meet high demand. Having a safe, high-capacity buffer like this makes it much more practical to rely on renewable energy sources that can't be turned on and off with a switch. You won't see these batteries in your house or your car, but they are becoming a vital part of the infrastructure that supports them. These liquid systems are already being used to protect hospitals and regional grids from blackouts, providing a steady backup that lasts for hours. As we move away from coal and gas plants, we are seeing them replaced by these quiet, safe rows of tanks. By turning the variable forces of nature into a steady supply of power, the flow battery is helping to create a more resilient energy future for everyone.